lesson 2. Now, in lesson 2, we are going to look at how computers understand human language. How computers are able to understand human language. How we humans see things displayed on the computer is actually different from what the computer sees. So we humans, yes, we see text because we are comfortable, and that is what we actually work with. So we see text on the computer, we see videos, but the question is, does the computer actually see text? Does the computer actually see videos? And then we humans, we see a whole lot of things. We can mention what PDFs, we can mention music files, and so many other things. We see them on the computer. But the question is, does the computer see these things just like we humans see them? No. The answer is typically no. Computers represent everything that we see on the computer as zeros and ones. These zeros and ones is what we know as what? Binary. So as we see text, as we see videos, as we see music files, the computer is seeing zeros and ones. That is binary. So I made mention of binary. Binary is actually a number system, and this number system is made up of only 2 values, and these values are 0 and 1. So it is a number system that is made up of only 2 members, that is 0 and what? And 1s. Whilst we humans deal with alphabet, we deal with symbols, and then we dealing with our normal text, computers actually deal with what? Binary, and that is zeros and ones. So as we see text, the computer does not see text. As we see symbols, the computer does not see symbol. The computer sees what? Zeros and ones. So the computer deals with zeros and ones. So I made mention of number system. Yes, I said that binary is a number system which is made up of what? Of zeros and ones. Actually, we have different what? Number systems, and I want us to take some few minutes to look at some of these what? Number systems. So we have a number system called what? Decimal or denary numbers. And these decimal numbers or denary numbers are actually what we humans, we deal with almost every day. When we are counting everything that we have to use numbers, we use what? Decimal numbers. And it is also known as what? Base 10. Base 10 numbers, which is made up of only 10 digits, starting from 0 to 9. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so from 0 to 9, making 10 what? Members. So as binary is made up of only 2 members, decimal or denary numbers or base 10 numbers are made up of what? Of 10 members. So we have already spoken about what? Binary numbers, which is made up of what? Of only 2 values, that is 0 and 1. And that is what the computer actually deals with. It is not only these 2, the decimal or the denary numbers and then the binary numbers that we have. As I have said earlier on, we have so many. So we have another one called the octal numbers. Octal numbers, which is also made up of what? Of 8 members. So these octal numbers are also known as what? Base 8 numbers. Base 8. So it has only 8 members. So unlike decimal and then binary that are having 10 and 2 members respectively, the octal numbers or the octal number system is made up of only 8 what? Digits. And then the last one I will add to the number systems we have is hexadecimal numbers. So hexadecimal numbers is also a number system which is made up of what? 16 values or 16 what? Members. So it starts from 0 to 9, and then it continues with the 6 first alphabet that we have. That is A, B, C, D, E, F. So we have 0 to F. It is made up of what? 16 digit what? Numbers. Also, we can term it as what? As base 16 numbers. So these are just few. We have base 3, we have base 4, base 5, and then the rest. Good. So number system. And the number system that the computer deals with is what? Is the binary number system. A system of zeros and what? And ones. So every number in binary can be represented in binary. So every number that we can actually write in what? In binary or decimal numbers or base 10 numbers, we can represent the same number in what? In binary. So as we have 34 in decimal numbers, we have what? 34 as what? 100010 in binary. So we have 34, that is the binary what? Representation. Then we have 289, we have its binary representation as 1000111101. That is the binary representation of what? Of 289. Then we have 12, which its binary representation is 1100. So how do we convert from binary to binary? How do we convert from binary to binary? Yeah, this is a topic on its own that we have looked at. So you can watch that particular video too on how to convert from binary to binary and from binary to binary. So moving forward, we said earlier on that how humans see things displayed on the computer is different from what the computer sees. So as we see text and then we see videos, we said that the computer actually see what? Zeros and ones. That is binary. And how is this actually possible? That as we see symbols, we see text, and then we see what? Videos and the rest, the computer is seeing zeros and ones. And how is this actually what? Possible? Now let's look at it. Human symbols and computer what? Binary. Now all symbols such as alphabet, emojis, and then text, or the symbols, the characters that we humans deal with, these characters are assigned to unique numbers. So the characters that we humans are comfortable with, these characters, all of them are picked, and then each of these characters is assigned to a unique what? Number. So all human symbols are assigned to unique what? Numbers. So let's look at it. So we have symbol, the number that it has been assigned to in binary, and then the binary representation of that what? Number. So we have capital letter A, which 65 has been assigned to it. And then the binary representation of 65 is 10000001. Then we have small letter a, which 97 has been assigned to it. And that is the binary representation, which is 11000001. Then we have capital N, which has also been assigned the number 77. And the binary representation of 77 is 10011001. Then when we talk of small letter m, yes, it has also been assigned the number 109, which its binary representation is 11011001. Then we have character space. When we type and then we press the space bar to create a space between our words, as we are seeing space, the computer is not seeing space. The computer is seeing zeros and ones. And the space that we create has also been assigned the number 32, which its binary representation is 100000. Good. So every character that we humans deal with, numbers have been assigned to these characters. So when we type A, the computer does not see A, the computer sees 01000001. So what happens is that when we type A, the computer at the number that has been assigned to A and then represent that number. So when we see A, the computer is seeing the binary representation of the number that has been assigned to the letter capital A. So when we type M, small letter M, when we see M, the computer does not see M, but the computer sees the binary representation of the number that has been assigned to M. So when we type M, the computer sees the binary representation of the number that has been assigned to M. So let's look at them. When we type AMA, capital letter AMA, when we type AMA, we see AMA, that is symbols or characters. But the computer sees this 0100001110110011100001. So what is happening here? When we type AMA, the computer actually picks the number that has been assigned to each letter and then represent it. So when we type AMA, remember that the character A has been assigned a particular number. The character M has been assigned a particular number. The character A has also been assigned a particular number. So what happens is that when we type AMA, as we see AMA, the computer picks the numbers that are assigned to each character and then converts it into binary in order to be able to represent those numbers. Now, the question someone will ask that, so who are those responsible for assigning numbers to human characters or human symbols? So we have organizations that are responsible for doing this, and we call it what? Character encoding. Character encoding. So we have organizations that are responsible for the character what? Encoding. And the first organization is an organization known as what? ASCII. ASCII, American Standard Code for Information Interchange. So ASCII is one of the organizations responsible for character encoding, that is assigning unique numbers to the characters that we humans are comfortable with, or to human symbols. Then another organization that is also responsible for this character encoding is a Unicode Consortium. So Unicode Consortium is also one organization responsible for character encoding, that is picking human characters or symbols and then assigning them to unique numbers so that the computer can actually represent those symbols or characters. So these organizations are responsible for what? For the character encoding. Now, before we end this lesson, I have this activity for you. I want you to type what you have learned in this lesson at the comment section, and I will promptly give you a feedback. So whatever you have learned in this particular lesson, I want you to type that at the comment section, and then I will promptly give you a feedback. Now, this is the end of lesson 2, part 1.